All right. Well, hello everyone. Can everybody hear me out there in the live chat? We have 7 people watching. Dapper, you're both watching and in the show. How is that even happen? How is that possible?
It's called having another window open. It's a very advanced computer technique. I'll tell you about it later.
That sounds very convenient. But at any rate, hello everyone. So today we are doing a little bit different. The show normally we do our Thursday live streams, but today, it's we have Peter, who is producing for us as always, and then our guest or our co-host today is Dapper Dinosaur, the one and
Thank you.
only. And then we have a creationist on today, Rob Groen, right? Did I pronounce?
Yes, that's
Okay,
correct.
cool. Well, welcome to the show.
That's not correct,
Thank you.
Jackson. It's Groen.
All right. Well, I didn't want. It wasn't that big of a deal to me.
Oh, I'm sorry.
just kidding.
I'm terrible with pronunciations.
Well, my first name is easy to pronounce, so that's good enough.
Okay, well, good.
Yeah, I plan to just call you Rob. So
Yeah.
Yeah, Rob. Yep. Okay, so for anyone who is not aware, you just happened to accidentally stumble, via the YouTube algorithm over to this channel. Welcome. I'm Jackson. For those of you, we're going to discuss. You mentioned creation and evolution today as your talk, or as our topic. Sorry. And there are, as someone who has written one book on this subject and is in the process of writing a second one, that is an extraordinarily broad field. So we're gonna narrow it down. First, a couple of things that aren't really relevant to the discussion that I think we can dispense with, so they don't kind of trip us up and get us stuck down irrelevant paths. For instance, like whether or not God exists is not relevant to this topic. We can all just assume, for the sake of argument, God does exist. Fine, well and good.
I'm good with that.
Yeah, that's fine. That doesn't matter. And then the other thing is, evolution is, of course, the process of evolution is agnostic to any mechanisms of the origin of life. So whether God snapped his fingers and created the first life, or life was natural or totally naturalistic, either way, evolution is agnostic to that process. It just doesn't bear on it whatsoever. Sound good?
Mhm.
I would
We
also
can
say
do
the same thing about the origin of the planet, the solar system, the galaxy, the wider universe.
Yeah,
Right.
I agree. Evolution doesn't concern itself with origins, but how what happened after that.
Cool. Right.
Yep,
Okay.
I would agree.
Okay. So that aside, okay. I would also like to get us a handle on a definition of evolution. Evolution, as it has been traditionally defined in the biological literature since the 1930s, 40s, has been a variation on change in the genetic composition of a population over generations. Typically, you get the Theodosius Dobzhansky definition, which is a change in allele frequencies in a population over generations. Right.
Hmm.
And we can agree that's kind of the broad definition of.
Well, the thing is, I think that's where you get the dicey definitions between micro and macro, and I think they're distinct. But
So
you would
that's
obviously think they overlap.
so there's a that was actually the next thing I wanted to address, was the differences, why there are differences between the words micro and macroevolution, because that's actually very deeply entrenched in the history of evolutionary thought.
Mhm.
I'm not sure if you're familiar with the sort of early history of evolutionary thought, like in the early 1900s.
Like if we're talking about about what's his name, the guy that Darwin got a lot of his ideas off. His name escapes me.
Well, that was like 1800. That was early 1800s. Talking about
Yeah,
early
so
1900s.
it's for 1900s. No, not so much.
So the reason that micro and macroevolution are defined the way that they are, which Yuri Filipchenko was the Russian entomologist who defined those terms in 1927. He defined microevolution as genetic change within a species, and macroevolution was genetic change at or above the level of species, thereby including speciation. So speciation.
No one in the right. Yeah, I would say no one in the right mind would say changes within a species is not, of course that's observable.
Right. So those terms were defined the way that they are because when those terms were defined, there was a debate between two competing schools of evolutionary thought. Called, one was the Darwinists or the neo-Darwinists, and then the other was the mutationists. And so the Darwinists argued that all evolution was like this small, gradual, incremental changes within species that would ultimately result in separate species. But the mutationists, on the other hand, of which Philip Chenko is in that group, and Hugo de Vries and a number of others, they argued instead that mutations could never actually carry you from, or like small minor mutations could never change a species into a new species. That required macro mutations. So basically, you had like your small mutations within species, but then to go from one species to another, you had to have a macro mutation, right? So that's the reason that those terms are defined the way that they are, because
Okay, well, I'm glad you laid out the terms because I agree with your definition of the terms, so that's helpful.
Okay, and I also figured that you'd probably agree based on the way that you, or one of the arguments that you made in your tweets. So we can agree that macroevolution includes and extends beyond like divergent speciation, right? So going from one species, splitting into two, and then everything beyond that. Okay, cool. Okay, so with those definitions in mind, Dapper, did I miss anything or?
Not that I know of, although it sounded pretty good. I do want to point out that the idea of macro mutations as a necessary component to speciation has been long since abandoned.
Right. Yeah. That's so given that, you tweeted, well, you made several tweets, and I quoted a couple of them as saying, so, well, really the most relevant one here is, you said, now there are several problems with this, referring to macroevolution. The first and foremost being limitations in the gene pool of each species. What I mean by that is there is simply no way for divergent speciation to ever occur because limitations in the gene pool of each species prevent divergent speciation from occurring. Close quote. Does that sound fair? Is that a fair characterization? Okay.
That is.
So, given that, I think what would be most relevant next, kind of, maybe I should do that a little bit. Is that better? There you go. Next to it seems relevant to define what a species actually is, right?
Good luck.
You're the scientist, so I'll let you define it.
Okay, well, there are lots of different definitions of species. I have a book by Jerry Coyne and Alan Orr. It says
Just give me and the audience a general.
So the most commonly used definition of species is the biological species concept, which Ernst Mayr coined back in 1942, which says two populations are considered the same species if they can interbreed and produce fertile offspring. Yes?
Yes, I would agree.
Sound good?
I would agree with that.
Okay, so if we can produce a population which budded from, a new population which budded from a parental population, and that new population can no longer interbreed with the parental population, that would be an example of speciation according to the biological species concept. Yes?
Agreed.
Okay.
Agreed. Yep.
And yes, Nebula, and I know species are constructs. We're not worried about that right now. It's a separate topic.
I mean, I'm a little bit worried about it.
Well, I mean, we can certainly get into it if it becomes an issue, but I mean, I think for our relevant purposes right now, it's not really an issue. So, given those premises, which I think we both agree, so macroevolution includes speciation, and speciation involves the reproductive isolation of a population from its parental population. If we can produce an example of a reproductively isolated population and identify its parental population, we've demonstrated observationally macroevolution. And I think that's okay. So I would like to give several examples in which we've done that for the last, it's the 2024, so the last like 60 years or so.
Sure.
One of the first instances of this occurring was Theodosius Dobzhansky, and there was another guy, Pavlovsky, I think. They raised fruit flies in the lab back in the 1960s, and one of the fruit fly species they worked with was Drosophila polystorum, and they had a specific group of these, which is called, I think it was Lanos-A, and this population was separated from the others and allowed to interbreed on its own, and over the course of, I think it was like 5 years, they became reproductively isolated. So they tried to They didn't even think about it. They were just like, we'll just keep these separate, keep them away from each other, and then we'll come back and we'll use them for our experiments. And then when they tried to interbreed them, they no longer could interbreed. They had, per the biological species concept, formed a new species, right? Because there are two populations. They are no longer capable of interbreeding and producing fertile offspring. And that occurred within 5 years. That's a human timescale, right? But of course, it's many generations for fruit flies. Yes.
But were they still only able to produce fruit flies?
That's not the question. Now,
No,
that's a common response, but that is not a response to the question. So
what that response is called moving the goalpost.
Yes.
Right now, the goal is demonstrate macroevolution. Later, if you want to go into things like what kinds are or whether or not we've demonstrated things going from one kind to another, we can do that. But right now, we're concentrating on does speciation occur, which means we're also concentrating on does macroevolution occur? Because those two questions are identical.
Yes.
Okay, well, I have a problem with the premise at the moment, but that's neither here nor there.
Well, what's your premise? Because you agreed to all these steps thus far, which is why I provided this specific example, because it meets all the criteria that we've now both agreed on.
Well, I mean, all it has proven to my knowledge is that something has changed significantly within the species, but it hasn't become another one.
Well, that's the definition of the species, right? Is a population which can no longer, two populations that cannot interbreed and produce fertile offspring are considered separate species. Now, these were originally one Drosophila polystorum population that was then split into different subsets. And now, after I think it was 5 years, it wasn't very long later, they are no longer capable of interbreeding when they try to cross them in the laboratory. So
that just means that the environments in which they're in cause them not to be able to breed anymore. That's about it, right?
But if they're not breeding anymore, if they are no longer interfertile with each other, they meet the definition, the biological species concept, as being two separate species, if they can no longer interbreed.
And that just mean they have reproductive issues?
They have reproductive isolation, which is
you
what
have reproductive
causes
issues.
speciation.
You have reproductive issues with, a Komodo dragon. Why? Because you're different species, right?
Yeah.
Having the reproductive issues to the point that it precludes interbreeding is what is different species. According to the definition that I want to remind everyone, you did agree to.
Yes.
If you would like to go back and say, well, actually, now I don't think that's a good definition for species, maybe we can talk about that.
Okay, I'll use an analogy.
Okay.
If we put a bunch of human beings in the same kind of situation, and all of a sudden notice that after 5 years they couldn't interbreed, would they be a new species?
Well, it'll probably take more than 5 years.
Yeah,
probably take more like 5,000 years or so.
Okay, but anyways, would that mean we have a new species of people?
Yes, that is what that means. Yes.
Okay, I disagree with that term. But
all right, what definition of species would you prefer to use?
Yeah.
Well, it has to be something. The species has to be able to continue to produce its own kind. For me, that would be the fitting definition of a species. You have to be able to produce your own kind.
So if two groups of organisms can reproduce together as separate populations, but they keep reproducing.
No, I'm talking about separate species. If you can produce a separate species, then macroevolution is scientifically.
All right, then maybe I'm not clear on what you mean by species, because before it was a group of organisms that can interbreed and produce fertile offspring. And then we gave an example of a group of organisms that started out being one species under that definition. Then later they could no longer interbreed.
I need to slightly alter my definition then.
Okay.
I mean that you can't, that whatever species you are, you'll never be able to produce another one than the original. Like a fly only produces a fly, human only produces a human, and so on and so forth.
So the thing with that is those are different taxonomic ranks. Those are not species. So for instance, fly encompasses an entire order. That's Diptera. That's
I can see to that. We don't need to belabor it. I can see to that.
All right, so I guess I'm not clear. What would be an example of speciation, given the species concept that it seems like we're all operating under, other than... let me finish the sentence. Let me finish the sentence, Rob. Let me finish the sentence.
Sorry.
So what would be an example of speciation under the species concept that we've all stipulated to agree to for now, other than having one species and then at a later time having two species, all of whose members are descendants of the original one species that you had at the beginning. Because that seems like it is exactly what speciation is. You have two species where before there was one. Go ahead.
Yeah, you're right. I think I'm confusing speciation from divergent speciation.
So, speciation just encompasses all the different ways by which new species form. So you can have like what's called reticulate evolution, which is basically when you get hybridization to form a new species. Like that happens with if fruit flies do that. There are lots of examples of like clownfish in the aquarium hobby where people will crossbreed different species of clownfish to produce new, species or varieties, whatever you want to call them.
It's in my mind, that's microevolution.
So that still counts as speciation, because what you can do when you
right.
get that sort of stuff is you can again, under certain circumstances, it's not always possible because sometimes you'll just produce like little hybrids who are still capable of interbreeding with the parental species. But in some cases, you can actually get sort of a mix where maybe the chromosome count is now different than either of the parents, and if in plants this occurs a lot, they like self fertilize, then you can get a new species, and that's reticulate. So it's two different producing one new species by hybridization, but that is also still macroevolution because that's still a new species which is unable to interbreed with the parentals. There's like what is it? The ragwort, I think, is an example of that in England. It was like a hybrid of a couple different ragwort species, and that happens in like our cultivars a lot. Is you get multiple wild species who cross, and then
On
that
top
results.
of that, many cultivars of plants and domesticated plants are also themselves produced via polyploidy and would no longer be able to interbreed with the initial cultivars that were originally
Right.
domesticated. So, for instance, a lot of plants have more than 2 copies of their genome per cell and would not be able to directly interbreed with plants that had a smaller number, which we know is what they used to have because we still have wild versions of all of these plants, which have the the diploid genome, or in a few cases a little bit more. Like a lot of plants in the nightshade family actually just have hexaploid genomes in the natural state, but in domesticated cultivars, we can then go further than the hexaploidy that they have naturally.
Okay, I have some questions. You want to
Okay,
ask them?
shoot.
Go.
So here's my questions. I'm gonna have to tweak some of them because of the rules we set out forth at the beginning. How can macroevolution account for divergent speciation when new genetic information can't be added to the genetic code for each species? How can life? Sorry.
Do you want to go through all the questions?
I won't make. I'll only have a couple questions. Just
Okay.
appreciate no interruption.
Yeah, sure.
I listen to you guys and appreciate you respect the same in return. Okay, how do you account for the vast amount of symmetry, uniformity in systems in the natural world with macroevolution as your bedrock of foundation, if you will? Commonality of genetic structures in different species do not prove or indicate a common ancestor or divergent speciation. It only proves just that commonality in the gene structures of different species, or to put another way, God didn't need to reinvent the wheel. Science deals with that which can be observed, tested, and repeated. Since no one can or has observed macroevolution, divergent speciation, or lower life forms evolving into fully formed functioning organs or organisms, or just complete beings as we are, it's therefore conclusively ruled out as scientific. You have the floor.
So can you restate or re-put to us your first question? Because I guess we could go through these like one by one. But yeah.
Sure. I said, how can macroevolution account for divergent speciation when new genetic information can't be added to the genetic code of each species?
Well, that happens all the time.
That's the first question.
Well, yeah, actually, I have one quick question. What do you mean specifically by divergent speciation as opposed to just speciation? Because unless I
divergent speciation.
Sorry, go ahead.
Okay, what I mean by that is one species over time, slowly given enough time, becomes another species altogether, or just a different form. Say, for example, a land-dwelling animal becoming aquatic.
So when you say speciation, species, or as we were talking about speciation, the process of species becoming separated from each other involves the isolation of their reproductive capabilities, right? So the whole of like the process by which a terrestrial even hoof mammal became a whale, that's numerous speciation events all being encompassed under
Of
that
course,
process.
yeah.
Or yeah, so when you say divergent speciation, what I think you're referring to is like one species becoming two, right? That sort of thing.
Yeah, exactly. Yeah. So
Yeah.
so the one you're kind of talking about, not my contention is there's no way that new genetic information can be entered into the genetic structure of a species, well, no matter how long it is to become from a land-dwelling animal to aquatic, no matter how much time is given.
What's genetic information?
Any kind of information that would require the changes necessary for this to happen.
So mutations are genetic information?
Oh, they are, but in almost every situation, genetic mutations are almost always a disadvantage.
Okay, so but that just means that now mutations just add genetic information. So
I would also
Yeah,
like to
but
enter
that-
another example in which we have the actual genetics of a speciation event. Because
Okay.
you say new genetic information cannot be added. An example in which I think addresses this would be like there's a crawfish called the slough crawfish Procambarus phallax, and an autopolyploid event occurred within this species
What
that
does that mean?
resulted. So autopolyploidy is when you basically fail to have the separation of your gametes. So when you make gametes and you make sperm or egg cells, you do meiosis. You don't do mitosis like your skin cells or your organ cells.
Okay.
And when that happens, you have do what?
I'm tracking. I follow.
Okay, cool. So you have your two full sets of chromosomes, and then you take one cell that has a full set of chromosomes in it, and then you turn that into four cells, four haploid cells. They each have half of the genetic material. So when that occurs, or so that's what's supposed to happen. You're supposed to have you're supposed to make sperm cells that each only have half the genetic material, so that when that comes into contact with an ovum, you then form a single individual who has one full set of chromosomes, right? That's just reproduction.
Mhm.
So what can happen is what's called autopolyploidy. Basically, one of the parents fails to do meiosis correctly and retain and makes a gamete then that still has the full set of chromosomes in it. So like it's still got two in it, and two full chromosomes instead of just the half. And so when that
Right, but
happens,
that's not really that's not really the kind of thing I'm talking about, though, Jackson.
I mean, you can also look at like one of the famous. I mean, I think it would be because again, we're talking about an addition of genetic material in the species that didn't previously exist, right? Like that would have been
But
divided up.
I was using like.
I'm listening.
Oh, your camera froze, man.
Oh, sorry. I'm listening. I can hear you.
I think we froze.
Can you hear us, Rob?
I don't think you can.
I don't think he can.
It's glitching.
It
Oh.
might.
There we go. I think it's
Okay.
working now.
Okay. We can hear you. We're listening.
Okay. Yeah, there was just a glitch. Everyone's camera froze for a second.
Okay, so what were you saying?
That
were
might
you
be
saying, Rob?
that might be because you have
Almost-
a low internet connection, Rob. If it keeps happening, then you might
Yeah.
want to turn your camera off. That will probably solve everything. But as long as it works,
All
it
right.
might be better
Okay.
to keep. Okay.
How's that?
I mean, I can still
How's
hear
that?
you.
Can you guys
Yeah, we can still hear
me?
you. Yeah, we can hear you.
Okay. All right. And you can see my avatar.
Yes.
Yep.
It looks surprisingly like you.
Yes.
So you were saying?
Was it glitching on your guys' end too, or just mine?
Nope, we
I
could
think
hear
it
you
was just
fine.
yours.
No,
Yeah,
that
we
was
could hear you.
it was just on your end, which is why I suggested maybe shutting the camera down helps.
Yeah. Yeah, it does, because the camera does take a bit of power.
Yeah.
Yeah, it's true.
Okay. Anyway, so what I was trying to say is that Jackson was giving a small example, but I was talking about a more extreme example of a land-dwelling animal becoming aquatic. I mean, I think Jackson was kind of heading on how it could start, but I don't think he gave the steps as to how it could
All right, well,
start it from starting
maybe,
to completion.
maybe it's that I might not be understanding exactly what kind of answer you're driving at. So maybe I can try to ask a few clarifications and see what I have. So
Sure.
what is it that you think is a barrier, say, to having a land animal adapt to be more aquatic over time?
Just aquatic period. I think, like I've said, I think there's limitations that prevent it from happening in the
Okay.
genetic code of each species. That's what I'm driving at.
But we're
So
asking, like,
there
what
are-
do you mean
Well, yeah,
specifically?
that's what I'm trying to drive. So are there
Yeah.
certain mutations that just
Oh.
can't occur because of some limiting mechanism that stops certain mutations?
Yeah, I just think that I believe that there's just we can't get from one thing to another. I think like whatever is aquatic will always be has always been aquatic will always be aquatic, and I believe that the same thing for land and animal-based creatures, that it's just everything just is as it always is. It's just there's no we are whatever is land-based and dwelling has always and will always be land-based and dwelling, and the same applies for creatures in the sea and in the air.
Right, and
The
I'm asking
creatures
what
fly in
prevents...
who fly in the air, but of course, no creature stays in the air forever.
Fair. I do want to apologize. There is a delay, and sometimes it might seem like I'm interrupting. I'm not trying to, but yeah, there's a delay, and sometimes I'll start and you'll be already talking by the time that it comes through. So I want to apologize for that. I'm not trying to interrupt. What I'm what I'm trying to get at is what is it that prevents that, right? Because we have mutations, and ultimately the difference between the genome of, say, a whale and a hippo is down to a number of changes to the genome, which themselves were mutations, as far as science is concerned. So if you want to propose that that's a transition that can't happen, what you need to do is provide something that would prevent it. Because as far as everyone else can tell, as far as all the scientists know, that's just what happens when you have mutation coupled with things like drift and selection, right?
Sorry, go ahead.
No, that was it. You're good. Go ahead. Sorry.
Okay, so my contention would be that most, from what I gather, and I mean I'm using a generalization, so don't come at me too hard for this. And my contention is that mostly when I hear about people saying that just happens, but from what I hear is time plus chance equals a new thing. But I don't see what I always see lacking, or if completely, if not entirely, is the how it happens.
So, if I may,
how does a land? Please, I'm still talking. So, how do you go from a land-based creature to an aquatic creature? Like, if it happens, then you have to provide the process and evidence of how it happens. Because, as far as I know, no one's ever seen it happen, which means goes back to my original premise. Means it's not scientific because it can't be observed, tested, or repeated.
So there are a couple issues with that. For one thing, we don't have to see every step in some process to be able to infer that point A went to point B. I mean,
No,
that's
but you have to observe it to be say it's scientific. You have to at least observe, or at least
you
reduce
don't.
it.
You have to be able to infer. You should be able to infer evidence about it, make inductions about or regarding it, but you
Maybe
don't
I
have
can
to
help here.
literally see
Well,
things
Jackson,
happen.
you know the scientific method literally deals with that which can be observed, tested, and repeated.
You understand that
You
evidence.
you can't make up your own definition of scientific just for your own benefit, man.
So you understand that when people say observable evidence, they mean evidence that can be observed, right? Like that's what that means. Like you have evidence that you can witness. That doesn't mean you witnessed the whole process happen. It means you have evidence of the process that is observable. So, for instance, if we have, say, a suite of fossils, for instance, that document most of the changes of going from a primitive even hoof mammal to like a whale, for instance, we can see how the hand and the skull and the nasal passage and all this changed in these fossils. The fossils are themselves the prima facie evidence that this happened, right?
What does that word mean, prima facie?
On the face of it.
Yeah.
Okay.
So
the thing is, you can see that changes happened but you're making a giant leap in logic as to what changes happened and how. That's my contention.
But
mean,
we're not though. We
what
don't have to
changes
do that.
happen are the changes evident in the fossils.
Yeah. So for instance, if you look at if you compare Pakicetus with Ambulocetus with so Pakicetus is a very early member of the whale lineage, and then Ambulocetus is a bit later member, and then Basilosaurus is a bit later member. If you look, for instance,
okay, I'm not familiar with those terms or words. Can you? Were they previously?
Do you have access to our side chat here? Our side chat?
Yes, I do.
Okay, so I'm gonna put in our side chat all three of those. Okay. You see Pakicetus, Ambulocetus, Basilosaurus?
Yes, I do.
Okay, so Pakicetus is one of the earliest members of the whales. It's still a terrestrial whale relative. It still has most of the features, especially the diagnostic characteristics of terrestrial even hoof mammals. Like it has the very specific wrist and ankle bones that even hoof mammals have. They have these very specific shapes of certain bones in their wrists and ankles.
Can I ask you a question?
Shoot.
Okay, so are you saying there's commonality in the genome structure that suggests that there's ancestral linkage?
Well, there is, but that's not what the point of looking at the fossils are. For most fossils, we can't get DNA out of. But yes, in fact, if you look genetically, the closest organisms to whales genetically are hippos, which is why we've reconstructed a plate called Whippomorpha, which is just kind of a portmanteau of whale and hippo, and then the Greek word for shape. So yes,
would you say it's fair to say you can't say that a hippo is the ancestor to a whale just because they have commonality in the genome?
Well, yeah, they're both extant now, so they would share ancestry, just like you and your fourth cousin aren't each other's
but
ancestors.
I'm saying you can't make the leap in logic that a hippo is the ancestor to a whale just because
no one's suggesting that. No one's suggesting
that. That's all I'm suggesting. That's all I wanted to make clear. That's all.
Okay, so Pakicetus, Ambulocetus, and Basilosaurus lived 35 to 45 million years ago, right? They're not around today.
You know this how?
Because we can, stratigraphically correlate the layers that they're in via a variety of methods, including radiometric dating. We can do chronostratigraphy. We can do biostratigraphy. There are lots of different ways.
Yeah,
now, I'm sure you'll want to.
Wouldn't radiometric dating also assume that the conditions then were the same as they are now?
Listen, if you want to go down that rabbit hole, the creationists have already admitted Answers in Genesis kind of already admitted defeat on that point. So we can go down that rabbit hole, but later. I want to continue on the point with this one.
I was just asking you questions.
No, that's fair. I mean, the heat problem is still unsolved by creationists, but
I mean, if you want my quick one sentence take on radiometric dating and why it is a reasonable thing to do, is that the only real assumption that is unevidenced within radiometric dating is that physics works the same way now as it has in the past, which is one of the basic assumptions that allows science to work in the first place. The only reason induction is allowable, which is basically the entirety of science, is based on the assumption that physics didn't just magically change in the past. So if you're willing hold on. If you're willing to abandon all of science, and I mean literally all of it, by saying, yeah, sure, maybe in the past physics just changed, okay, sure, then maybe radiometric dating isn't reliable. But you've also now just given up literally all of science, and we don't really have a reason to talk about science anymore. Maybe we should switch topics to who's going to win a Super Bowl.
That's a little bit brash, I think, but whatever.
So continuing on with the fossils. So with these guys who are stratigraphically long before we see any modern whales, even if you don't agree with the exact ages, we do see, in fact, we see a number of transitions, right? We see transitions in the skull, in the wrists and ankles, in the hands, in the tail, and the spine, and the hips. And this would seem to suggest, and these are the exact changes that were required by whales to go from a terrestrial ancestor to what they are today, right? Like, for instance, whales don't have little hooves; they have paddles, right? Or at least the front limbs are paddles. They've reduced their hind limbs. So they have these paddles. They have the blowhole, which is the nose, the mammal nose, is way up here on top of the head. And you can actually see in the fossils how it goes from being here to slowly moving back on the head. You can actually see it it all those points in the middle in different whale fossils. And so these are the exact changes that would be required for whales to go from terrestrial to now they're aquatic. And Ambulocetus in particular was not fully aquatic. It was semi-aquatic. It was amphibious. So, I mean, what specifically about, then to go back to what Dapper was saying earlier, like what specifically about these changes, which are all changes in organs and bones and whatnot, that whales share with all the other mammals? Like, what if those changes just couldn't have happened, and what would have prevented those from happening?
Well, my contention is I don't think they have. I think you just have different creatures, like I said before. Like I think all land animals have been land animals and have produced the same as their own, and same with aquatic or amphibious. I don't think we've seen this change or split or divergence thing that macroevolution purports. I think that it is what I just said.
I must be misunderstanding you, Rob. And I say that because what I just heard you say is the reason it couldn't have happened is because I don't think it happened.
Yeah.
That can't be what you meant.
No. It's because it's never been observed, is what I said.
Okay, so I want to ask a question. Rob, the tallest tree in the world is a giant redwood named Hyperion. How did it start out its life?
Small, I'd imagine.
Like originally, when it was the first time it was an identifiable individual, what was it? Was it a little seed?
Must was a seed.
How do you know? Have you ever seen a seed drop from a redwood to grow into an 800-foot tall tree?
No, because that's what the logic and the science and the induction would infer.
Oh, okay. So we can take long-term processes that occur longer than the span of a human lifetime and look at the steps between, look at how they logically follow from one to the other, and then infer an entire history for, say, some biological structure that precedes your life and is too long for any particular individual. Okay, got it. So I am now going to say that you no longer get to say, well, we didn't watch land animals turn into whales, therefore I don't believe it. Because you do believe that giant redwoods grow from from seeds, even though you can't see any of that happen either. And neither can anyone else.
Yeah, but you're using it to completely false dichotomy there, man.
Why?
No, the difference is you accept that redwoods grow from trees. You don't accept evolution. That's why you think it's a false dichotomy right there. I'm not actually presenting a dichotomy. I'm just saying
you're setting up a false dichotomy. I'm going to explain why. Because like you said, we can use induction and inference in science to know that a seed from a redwood would produce a redwood even 800 years, 1,000 years, even before or after I lived. That's no one's disputing that. But just to say that a redwood could somehow become a pine wood or a maplewood. That's what we're talking about here. That's
because no one's saying that.
No, but that's the false dichotomy you're using to use an analogy.
Okay, first, not only is it not a dichotomy, it's never mind a false dichotomy, because I'm not presenting you with two different options, of which I'm saying you have to choose one, even though third options exist. That's not what's happening. Second, no one is claiming that a redwood could evolve into any other extant tree species, because that isn't how evolution works. If a redwood evolved into another extant tree species, that would be a violation of how evolution works. That would overturn more or less everything we currently think we understand about evolution. So what I would like is, first, before you accuse me of setting up a false dichotomy, at least tell me what the dichotomy is, whether or not it's false, which, as far as I can tell, you haven't. Now, you might say, I think that's a disanalogy, and maybe it is. I would ask.
Right. I retract it. It's not a false dichotomy. It's a false way of looking at the world.
I mean, I don't see what's false about you saying that in some cases induction is okay, but it's not okay in this. Like, why is it that it's not okay when we look at longer periods of time and large groups of organisms, but it is okay when we look at a smaller group of organisms over a smaller period of time? What is it about the longer period or the larger group of organisms or anything else that makes you think that the induction that it requires for humans to conclude that giant redwood trees can grow from little redwood seeds, what is it about that is okay that does not follow for looking at, say, fossils and genetics?
Well, first of all, we can only infer so far into the past.
Why?
Secondly, well, I'm getting there.
Okay.
We can only infer so far into the facts because we can only make inductions and assumptions so long before we've gone from science to just our own presuppositions and confirmation biases. And every one of us has confirmation biases. Secondly, I don't think that we can be fair. I think again, kind of tagging onto that point, we're all reading, and I think to some degree or another, we all read into the data of the conclusions that we want. To some degree.
What conclusion do you think I want?
The ones that you're already comfortable with.
I feel like you are giving me way too much credit in terms of my level of comfort with almost anything.
Okay.
I don't know if you know, but I, in
think-
fact, spent the first part of my life as a young Earth creationist. And honestly, if that stuff were true, that would be great because that would solve a whole lot of otherwise perplexing, troublesome philosophical things that I have to deal with. It would just, poof, all of them gone. My life would be so much simpler. There'd be a lot less questions that I would have. Basically, I would love it for young Earth creationism to be true. If I could find a reason to actually think that the Earth were 6,000 years old and that there was separate ancestry between, say, humans and anything else that isn't a human, that would be great. I have come to the conclusion very much so in opposition to what I would prefer to be true. Now, I can't speak for everyone, right? There might be lots of people who would prefer the conclusions that science has reached to be true, but I'm not generally one of them. In fact, there are a lot of conclusions of science that I really don't like the fact that it'll probably always be impossible to travel faster than the speed of light. That sucks. There's a whole lot of the universe that no one will ever get to.
It's pretty quick.
It's pretty quick until you realize that, the galaxy is more than 20,000 light years across, right? Because that means I'm never going to ever, even hypothetically, get to see any more than just a little tiny bit of it.
Yeah, but you can still travel to the other side of the world under a second.
I mean, yeah, that's true, which would be cool. But overall, there's a lot about science that I wish weren't true, right? If the Big Bang, it kind of sucks compared to a steady state, because that means that, all of it's going to end at some point. That kind of sucks. I don't like that. Or if I could say that the universe were definitely a, divine creation, well, that might help. I don't think I can say it definitely is. I don't think I can say it definitely isn't.
Definitely can't say it isn't either.
I agree. I wouldn't make the claim that it definitely isn't. But a lot of the conclusions that you have, I would prefer to have if I thought they were viable options in terms of the actual evidence. So I'm not hugely sympathetic to the idea that I'm coming to this because these are the conclusions I would like to find. I mean, for one thing, I'm not even very happy with the current tree of the Artiodactyls. I miss when there was Suoidia was a group to which hippos belonged and whales didn't. I miss that, but I don't get to make up how Artiodactyls work. That's not my job. So sorry, I just monopolized that for too long.
Yeah, I was going to say you're getting a little long-winded, but I'm a patient person.
No, I get it. I'm done for now.
All right. Jackson, do you have any questions you would wish to ask me?
So, I mean, kind of back to the issue at hand is you've never supplied us with a reason to think why we shouldn't be able to go from a terrestrial organism to an aquatic organism. I mean, semi-aquatic organisms exist. There are lots of them. I mean, hippos are semi-aquatic, and they're the closest extant cousins.
I don't see a hippo as a common ancestor in any kind of whale.
I agree, but I mean, Ambulocetus, which I mentioned there, is a semi-aquatic animal. I mean, there are other ones. This is just an extraordinarily brief list. There's Remingtonocetus and Perucetus and Myocetus and all these other semi-aquatic whales.
And your point is?
Well, what's the issue here? I mean, we have aquatic modern whales, which were preceded in the fossil record by semi-aquatic whales, which were preceded by terrestrial whales.
Preceded doesn't mean necessarily that they have common they're an ancestor, a common ancestor.
So what you have to argue is that God decided for reasons unknown to us to create a series of transitional fossils and everything is unrelated to each other. But also,
I think that's a false way of looking in the data.
Well, okay, because these are as I mentioned earlier, these are the transitions that would have had to occur for whales to be descended from even hoof mammals, right? If
But the thing is,
that's not,
I reject the premise because I don't think they're really the descendants anyways. I guess I've said already a few times. I think whatever has been land animal, a land creature has always been a land creature
again,
and will always be a
incredulity.
land creature.
You're just offering us
Well, same for
incredulity.
you, man.
You're not offering
The
us
same,
any.
the same applies to you.
I haven't offered you any incredulity at this point. I'm asking you to give me a model that we can actually use to understand the evidence that we have currently. And you've just kind of said, "Well, I don't believe these things. I'm incredulous."
Observably, everything has always produced after its own kind.
Well, we
You
already
can get a dog
disproved
in-
this earlier. We disproved this at the beginning of the
You
conversation.
know, you've only
remember?
disproven that in your mind, Jackson. Only in your mind.
You agreed to the
All
definitions
right,
that
all
we
right, hold
provided.
up, guys.
I've also said I altered it later. Are you not paying
Okay,
attention?
hold up. This is getting a little bit contentious. Let's maybe bring
So-
it down a little bit. Let's ask a question. What's a kind, Rob?
Yeah.
What are those? Because we've now moved from species to kind, it seems like, which, I mean, okay, fair enough. If you think that, speciation can happen, but there's some other thing that can't happen, and that has to do with kinds, hey, that might be a perfectly valid dichotomy to make there. And, or, not necessarily dichotomy, you know what I mean? So what's a kind? What is that?
So, I mean, like, for example, humans
Mm-hmm.
can only produce humans.
Mm-hmm.
Dogs can only produce dogs.
Yep.
And so on and so forth.
Evolution agrees with you.
Really?
Yeah.
Yep,
Yep.
that's monophily. Yeah.
So I'm not seeing where the problem is.
There never can be a break or divergent or split from this.
That's
Yeah.
What do you mean when you say
evolution isn't about breaking? It's about continuity and
Right.
divergence with that continuity.
yes?
Okay, I would also argue that lower life forms can't produce what we have today as we are.
Well, I don't know what a lower life form is, but
Let's say lower bacteria organisms can't slowly evolve into what we are today.
So is all of bacteria a kind, or are there separate kinds of bacteria, or
No, I'm just saying that the theory is that kind of thing can't happen ever.
all right. So what I'm hearing here is that kinds are a lineage from which the descendants of the original members can't deviate from. They can't escape that group, right? Is that what I'm hearing?
No, they also can't become different. Like, for example, whatever you think our common ancestor is, we don't have a common. Our only ancestor is Homo sapien. Period.
So Homo sapiens is a kind.
Yes.
So are kinds the same thing as species? Because that's a species.
No. Well, yes. No, it's not the same thing because like you can have flies, but you can have different different species of flies. But
Okay,
flies can only reproduce flies. Is my point.
So horse flies, apple maggot flies, mosquitoes, bat flies,
Yeah.
which don't even have wings. Those are all the same kind.
Exactly.
Hey, Peter, can we show pictures? Is that a possibility?
Peter,
Peter?
you're muted.
I can't hear you, Peter.
Did he leave us?
He might have. Oh my
He just
goodness.
left. He said, "You know what?
I was just getting my coffee, and I thought this is a good moment, and then this always happens.
You guys can't see me, but I'm smiling.
Can you send it to me, Dapper?
So how would you like it sent? As an actual image, as a link, search term? What would you like?
Both would work. And if you have a link to a specific image, that would be best.
All right, so I'm going to pull up two images that I want. So the first one will just be this one. Let me, should I drop it in the chat or in your DMs on Twitter?
No, you can drop it here in chat.
All right, so that is a link that I would like to show, assuming that that's okay. If we
Okay.
could take a look at that whenever you're good and ready.
Yeah, I'll have to make a separate scene in OBS in order to show it. So.
Okay.
But I can do that fairly quick. So keep talking,
right, and then
I'll have it ready.
All right, and I'm going to send you a second one that you can show afterwards if I can get my Control-C, Control-V to work. because I don't know, maybe my keyboard is breaking. So anyway, so kinds are something bigger than species is one of the things I'm getting from you.
Yes. Yeah.
Okay, so and you would say fly is a kind.
Yeah, it's like there can be there's different kinds of there's different species of flies, but a fly can only produce another fly. Is my point.
Okay, but evolution also says that flies can only produce flies. From now until the end of all life, if flies last that long, all of the species produced by dipterans, which is the group, that's the scientific name for the fly group, right, will always be in the group Diptera from now on. Just like they'll also always be insects, there'll always be hexapods, there'll always be crustaceans, there'll always be arthropods, there'll always be protostomes, there'll always be bilaterians, there'll always be animals, there'll always be eukaryotes, right? You never lose any of the stuff that's farther back in your ancestry according to evolution. You'll always be a fly because you're a fly now, and your descendants will always be flies. Similarly,
got the picture ready.
Okay, so let's show the first one.
Oh, my first.
So this is a fly.
First question?
No, the first image.
Yeah, the first image.
Oh, yeah.
So this is a fly. And let's go to the second image.
Oh, I haven't got the second yet.
Peter, you're killing me.
I know. Peter, you're fired.
Yeah, Peter, we're
not even getting paid.
See, this is why I usually say if people want to show things, I need to have that.
Well, I didn't know I was going to want to show it.
See?
So yeah, you would agree that was a fly though, right? That fruit fly that we just saw, that was a common fruit fly, which I believe is Drosophila melanogaster.
And
Rob, you would agree.
The second one has a lot of pictures. Which one do you need?
Oh, okay, hold on. Let me see what I can do to fix that.
I can't show the whole thing if you want me to.
Yeah. So. Let me see if I can open this. Let's see if this link works. Sorry about this, everybody. I was not super prepared, so yeah, this should work because the URL actually ends in .jpeg, so that should just get you the actual picture I was looking for. Sorry about that. That's my bad.
No worries.
Wow, how embarrassing! Imagine being you.
Yeah, no. Well, I mean, look, you humans in newfangled technology. We didn't have this in the Jurassic. In the
Jurassic cast is ripping you apart, Peter.
You get what you pay for, Jackson.
I suppose there's truth to that.
So anyway, but yeah, so that was a fruit fly, and it's always going to have flies, right? Like, there's no disagreement about this, but it could vary significantly. What if it got a giant spidery-looking body and no wings, and lost most of its head, like these guys? These are flies.
Right. Okay.
I mean, if you saw those two in isolation, would you honestly tell me that you think that that's the same kind as that fruit fly? Not the guy in the middle, that's a bat.
No.
But the two on the outside.
Yeah. Obviously, they're much different looking than the first one you showed.
To me, that seems like it's way more morphological difference than, say, there is between like a human and a chimpanzee, right?
A lot more, yeah, because we're talking different families.
Yeah, I would agree, but I mean, if we're still talking in the families of flies, and it's a different species of fly, but it's still a fly. That's my contention.
But the thing is that evolution says that humans are just another species of ape, right? They're both hominids. Humans, chimpanzees, gorillas, orangutans, they're all just hominids. Humans are a particular group of hominids, right? They're the hominins, or the remaining hominins, as opposed to the panins, or the gorillans, or the pongans. Right.
And again, my contention is still that humans have always been the way we look like. Well, maybe not totally the way we look like now compared to maybe thousands of years ago, but there's still not enough of a difference between now and thousands of years ago that I could say, okay, that's definitely not. Like the example you showed. That's what I'm saying.
So you do think it's possible for a fly somewhat similar to the fruit fly that we've shown, because that's a pretty basic fly, right? That something like that could evolve into something like those bat flies that we also saw. But it's not possible for something like Ardipithecus ramidus, which is a somewhat skinny, kind of lanky probably palmigrade ape from the early or I don't remember which part of the Miocene, from the Miocene, that could not diverge into the stockier, mostly ground-dwelling, mostly quadrupedal chimpanzees versus the still somewhat lanky bipedal humans. Like that's way beyond possible, even though that's way less morphological change than to get from a fruit fly to a bat fly.
Well, I don't know enough about each genetic structure of each species to make a comment on that. But like I said, I would say that the kind of change that you showed between those two flies to what we can what happened in the human population, I'd say it's much less likely to happen in our genome than the one you showed.
I mean, the human and the chimpanzee genome is way more similar than the the fruit fly and the bat fly genome.
Agreed.
So, like,
but again, my contention is that the human that all that proves is commonality in the genome and nothing more.
All right, I would love for you to tell me how that isn't special pleading.
How that is not special to me?
No, that's
Special
not special
pleading.
pleading, right?
Pardon?
Pleading.
Oh, special pleading. Oh,
Yes.
I see. No, because I don't think it is. I think that's just logical. You can't just infer that we have common ancestors or splitting somewhere in the genome just because we have common genetic structure. That's a leap in logic.
I know you don't think it's special pleading. That's why you said it. But I would like it if you could explain to me why it is that much more or much larger amounts of genetic and morphological change can happen in one lineage, but it can't happen in the ape lineage. Why is it
just have to
one
come,
is special?
It would just have to come down to that thing with whatever is in the gene pool of whatever species we're talking about.
So you're basing it on you think that there's some unspecified difference in the gene pools that you don't currently know about, but that you hope that someday someone might find it, or maybe they already have found it and you just haven't learned about it?
No, I think that the gene pool of most species have been proven demonstrably about which can change over time and which can just with the things we've already established in this conversation.
You're right. It has been proven as much as anything in science is proven, it has been very well demonstrated that the entirety of the genome can vary to an arbitrarily large degree over time. That has in fact been well demonstrated. Yes.
Agreed. Yes, I'm in agreement with you there.
Okay, so I still don't understand what the problem is.
Well, I still think I think the problem is at some point, again, we can only infer into the past so long, and we can only infer to the past so long without making where we're going from science to leaps of logic and faith.
Okay, so it's not a leap of logic and faith to go from a basal fly, kind of like a fruit fly, to a bat fly, but it is a leap in logic to go from Ardipithecus ramidus, which is actually more human-like than it is chimp-like, really, in most ways.
It always falls on our side of the tree, yeah.
Yeah, but going from that to both a chimpanzee, well, actually, would going from Ardipithecus ramidus to a chimpanzee be a leap in logic, even though Ardipithecus ramidus is more like a human than it is like a chimp in most ways?
Sorry, can you repeat that question? I didn't quite hear.
Would it be a leap in logic to say that the chimpanzees, so both Pan troglodytes, the common chimpanzee, and Pan priscus? I can't remember. Peniscus. There.
Anyway,
I can never remember.
Don't worry about the pronunciation.
So that's the common chimpanzee and the bonobo. I would assume that you were okay with those two having a common ancestor, since, I mean, most people can't even tell them apart.
Well, I mean, yeah, because if there's breeding, yeah, but again, as long, yes, we're talking about kinds, right? So if you can have a chimp.
My question is that something you could see as having descended from an organism like Ardipithecus? Is that a leap too far?
I don't know Latin.
Well,
it's a fossil ape.
Okay, so
maybe the name Lucy helps.
Well, that's Lucy is Australopithecus, and it's much farther along the human line than Ardipithecus.
Why is science always stuck in the dead language of Latin, anyways?
Carolus Linnaeus wrote Systema Naturae in Latin, and he is the one who created the binomial nomenclature system that we use. And he primarily drew on Latin and also Greek, especially when he needed two terms to mean the same thing. Like Ursus arctos is the brown bear, And Ursus is just Latin for bear, and Arctos is just Greek for bear, which means the brown bear is the bear.
Or gorilla for the Western gorilla.
Well, yeah, that's just the gorilla.
I think the moose is also the same. But anyway.
But also, it's not. There has been some. There's been some reaching away from Latin and Greek. There's been a few scientific names put out in Hawaiian.
Anyways,
Chinese becoming more
we're
common.
getting sidetracked from the conversation itself.
Honestly, I was trying to cover it in hopes that you were Googling Ardipithecus because I put it in the chat.
No, I don't Google at the same time I debate. I find it too distracting.
Okay. Well, Ardipithecus is in fact a Miocene ape. It's palmagrade, or it seems to have been palmagrade. It was probably mostly the semi-arboreal. It had a much more human-like hand than it has a chimpanzee-like hand. It was not adapted, most likely, for knuckle walking, because again, it was probably palmagrade instead of knuckle walking. And it is currently seen as morphologically similar to what we would expect the common ancestor of the chimpanzee and the humans to be like. So what I'm wondering is, could you see that as an ancestor to chimpanzees? Would that make sense to you?
Yeah, I could see that. That's not a leap in logic to me. Pardon?
But not an ancestor to humans.
No, I can't see it as an ancestor to humans.
Okay, now I want to add into this the fact that basically all the paleoanthropologists who checked would say that Ardipithecus ramidus is in fact more like a human than it is like a chimpanzee overall.
Yes.
Okay, well, according to the genetic structure you're talking about, right?
No, because we don't have
morphological structure.
This is a morphological question.
Oh, okay. Meaning it can morph into
the
that.
fossils.
It's more probable to morph into one than the other. Is that what you're talking about?
No, what I'm saying is right now, the anatomy, as it's understood, the anatomy of Ardipithecus ramidus is more like a human anatomy than it is like a chimpanzee anatomy.
Okay.
So it's a smaller step for it to go from Ardipithecus to Homo sapiens, or well, just Homo, than it is to go from Ardipithecus to Pan. And one of those you're okay with, but the smaller change, the one where there's less actual adaptation and morphological change that has to happen, suddenly you're not okay with it because it involves humans. And once again, it just sounds like you're special pleading.
It's not really because it involves humans. It's never been observed.
What's the it there? Because now I don't know. Ardipithecus has been observed. We have the fossils of it.
No, but I mean, we've never observed anything becoming us, like as a common ancestor.
We've never observed a fruit fly evolving into this bat fly. We've never observed that either.
But you're okay with that one.
We've never seen an organism being created either. Sorry.
Also true.
Yeah.
Also true.
Okay.
I mean, like I said, I think at some point we're just going to have to take it on. Well, okay, what are we inferring? What are we inducing? And how are we interpreting the data that we're looking at? I mean, we're all doing that, right?
So I think you're doing that, but you're leaving parts out. You keep saying it's a leap in logic, but what we're not understanding is what the leap is. Like, it seems to us that you're allowing for this continuous line of logic to exist between two things that are more distantly related. They're way more different from each other than we are from either Ardipithecus or chimps. And you're allowing...
And I could be wrong with that too, because I'm not a scientist. But...
Well, it's just the point is that it seems to us that you're allowing for a greater difference to be encompassed by, this kind, but for a much smaller thing, you're not allowing for that to be encompassed by a kind. And we're trying to understand what the reason for that is. That's what we're not
doing.
And
like I said, I could even be wrong about that. I mean, like I said, I'm not a scientist, so I'm trying, and I'm more into, like, I can understand scientific terms, scientific principles, and I'm pretty logical for the most part, but I still have room to learn and grow like everyone. But I think there's still, for the most part, like I said, this is why it's important for us to get the terms right. That obviously microevolution, no one in the right mind can deny, because it's observable. We see microevolution, we see adaptation, we can see different dogs producing a different dog.
Right.
Like a golden doodle can get together with a Labrador, and they can produce something that resembles some variation of. But we don't see a dog and a cat produce something.
Well, again,
that.
evolution does not expect that or entail that.
Oh, I
That's
know,
just
but I'm only saying it to
right.
clarify terms.
Okay,
right?
so but here's the thing. The transition from like a fruit fly, basil fly, to the bat fly would involve macroevolution, like necessarily, because as we established earlier at the beginning of this conversation, macroevolution entails speciation. So to go from one to another, you'd have to have likely many successive rounds of speciation, because they're not just different species within the same genus; they're different like families within the same order. They're quite different from each other. They're way more different from each other than we are from any of the other great apes. And so so that would require macroevolution to go from the fruit fly to the bat fly. That would require but you've said it seems that you accept that that's allowable within your world.
Well, I'm just again I'm stretching myself here because again, like I said, I'm not a scientist, but I understand scientific principles and concepts. But
I understand. I understand that.
okay, but okay, I'll try to explain this as best I can. There are allowances, like like I said, you can get different kinds of fruit flies can come together and mate, and I'm sure we all agree that can happen because that's observable and testable and repeatable. But can you get from a fruit fly to I'm only using this as an anomalous, all right? I'm not saying this can happen. This is completely hypothetical and just anomalous. You can't get from a fruit fly to, like, say, I don't know, a gnat.
To a gnat?
Why not?
Maybe you could get so you get from that. You can go get from a fruit fly to, like,
because those are both Diptera.
You can go from a fruit fly to a bat.
Yeah, everyone agrees with you there.
Okay,
I mean, so again, the common ancestor of these two would not have been either like a bat or a fly, right? It would have been very different from either. But the common ancestor of both would have been a bilaterally symmetrical animal, because both bats and flies are bilaterally symmetrical animals.
And they share numerous
that doesn't
developmental
prove
genes.
common ancestry. That just proves symmetry and DNA, same commonality.
Okay, but at this point, I'm less interested in proving common ancestry to you than getting you to stop straw manning it in the first place. Honestly, because the thing is, I would like it if people who disagreed with the science on this topic were actually talking about the science on the topic instead of the version of the science that they think is what the science says that isn't, right? Because I think
okay. I'll just ask Jackson then tell me what you think macroevolution is, allows, and does.
Well, so as we stated at the beginning of the conversation, the definition of macroevolution is genetic change at or above the level of species, which includes speciation. So macroevolution is really just, it's not a process. It's just a description of the fact that speciation happens repeatedly, right? So you have successive rounds of speciation within lineages, right? So, and that's really it. That's all macroevolution says.
Yeah, but that's a really broad term. It needs more specification.
No, it's actually everything is quantifiable. Everything within that definition can be quantified. Like we can say we can give a definition to species. And so we can say when we can obviously quantify genetic change. I mean, that's what geneticists do all the time. But we can quantify both of these. And so that's not really a broad term. Just saying that you have genetic change at the level of species or above. I mean, like I said earlier, this is a term that came out of a particular time in the history of evolutionary thought. Now, creationists have decided to die on the hill of we can never allow macroevolution, which they don't have to. That was never a thing they had to choose, right?
No,
and in fact, if you read...
The fact that it's a choice means it's just that. It's a choice.
Well, right. If you read Answers in Genesis, they actually require macroevolution. So, for instance, if you read Answers in Genesis, they'll say that the common ancestor of Canidae, the family of dogs, right, was on the ark. And then the pair got off the ark and then diversified into all the species of canids that currently exist: foxes, jackals, wolves,
and
dogs,
the extinct ones.
And the extinct ones, like the borophages.
That's microevolution, not macroevolution.
No, that is macroevolution because that's speciation occurring. Wolves cannot interbreed with foxes. They are different genera, not just different species. They're
right.
So
Right.
so that is macroevolution because they are unable to interbreed and produce fertile offspring per the biological species concept. Now we could say, oh, I take issue with the biological species concept, and listen, Dapper and I will agree with you all day on that. It's there are problems with every species concept, but that's
Mhm.
more because evolution is too fluid rather than than anything else. But
Well, I think that's what's one of the problems is there's several different types of evolution, and
again, it's not really sorry.
a lot of times people will switch from macro to micro when most people won't even know the difference.
Well, again, macroevolution is not a process. It's a description of the processes of evolution, all of which are microevolutionary. So
Sure.
evolution, starts with you have variations, right, which are the result of recombination and mutations. And then those variations are acted upon by either selective pressures, so you have natural and sexual selection, and then there's also genetic drift, which is the random fluctuation of mutations within populations. So most mutations are actually neutral; they're not deleterious. They just have no effect essentially whatsoever. And so then
Most mutations are disadvantage.
they're actually
That's-
neutral. They're actually neutral.
Verifiably, measurably wrong.
Yeah,
We
they're
can
mostly
check.
neutral. And we've known this since like the late 60s, because that's what this neutral theory of molecular evolution. So most mutations are neutral, and as a result, they randomly fluctuate throughout in their frequencies throughout the population. So that's another microevolutionary mechanism. And then you have also gene flow, which is the crossing of genetic material between populations. But natural sexual selection, genetic drift, these are what lead to speciation. So it is microevolutionary mechanisms typically, except for like when macroevolutions happen, or sorry, macromutations happen, that's what causes speciation to occur. So micro and macroevolution are just descriptions of the process itself. They are not mechanisms. Do you see what I'm saying?
Agreed. Yeah,
Okay.
yeah, I agree.
Okay, so given that, the transition from like everything we've talked about today, from like one species of fly to another, or from these terrestrial whales to aquatic whales, all of that requires these microevolutionary processes that are occurring successively over the course of generations that lead to speciation, and then speciation events happen over and over and over again. We can observe this, throughout the fossil record. We can observe in very small timescales speciation events happening in our own lifetimes. I mentioned Drosophila polystorum, Procambarus virginalis, and then, I mean, that's the basis. Like we can see the basis of this process, and then we can extrapolate it over time, given the fossil record. And it's not just everything is like these huge, massive changes, right? Evolution is not always like land thing becomes water thing. A lot of times
No,
it's
I know,
just
I know. I'm
yeah.
not saying it always does either.
Right, and that's fair. A lot of times evolution is just like you can actually see in the fossil record in some species, if the fossil record's really good, you can actually see microevolutionary changes within populations. Right? So like if you look at things that have really, really good fossil records like phytoplankton, forams, diatoms, radiolarians, things like that, you can actually look at like how the shapes of their shells change very slightly as you move up or down the layers. What'd you say?
Yeah, okay, now you're mentioning it, let's talk about the fossil record. Now,
Sure.
the fossil record was found where? Tell us where.
All over the world.
Yeah, but where? But like, was it found on like the top of a mountain, bottom of a mountain, on top of a ridge, bound a ridge, or everything in between?
All of those and everything in between are
I mean,
places
yeah.
where fossils can be found in some places.
Right.
Yeah.
So a lot of times fossils were actually found where there was actually large bodies of water.
Yes, the majority of
can
sedimentation
happen.
occurs in water, which is why the majority of sedimentary deposits are in fact waterborne. Yep. Not all of it though, but yeah,
Okay.
most of it.
Yeah, there are like desert deposits, so
Yep.
that also
There's
happens.
desert deposits. There's also things like tuff, which are deposited by volcanoes, and their subaerial tuff is a thing, which is also frequently contains.
Okay.
bone.
So my question is, given that they were large, and most likely, were like you said, a lot of them were actually moved from the bottom to the top, and they formed at the top of where they eventually settled.
Hold on, you lost me there.
I'm not sure what you
Okay.
mean.
Okay, so a lot of the fossils and fossil records around the world were found at the top of what would have previously been large bodies of water.
I depends on what you mean. I mean, some
Yeah.
fossil spots are marine or
Some are
lacustrine.
marine, yeah.
Some are
Some are
desert
marine.
depots. I mean, it's a huge
I'm saying,
variety.
I'm trying making it simple, man. I'm saying some are marine. I'm
Some are
not trying to
marine.
make this.
Sure.
Yes,
Okay.
I agree. Some were
Some are
marine.
marine. Yep.
Okay. So, I mean, even regardless of whether some are marine, some were amphibious, whatever. But how do we look at the fossil record, even using radioactive dating, and determine how long it was ago? Like, I really struggle with this.
So
So maybe help me with this.
okay, so for one thing, you actually, in some cases, originally when the concept of the fossil record was first posited, radiometric dating did not exist. It just wasn't a concept because
Right. I understand.
atoms weren't even a concept yet.
They
And
were a
so,
concept.
I mean, they
Jackson.
weren't
The
a
ancient
scientific
Greeks
theory.
came up with
They weren't a
atomism. Come on.
scientific theory yet. Okay, Democritus. Anyways, the fossil record, as it was originally conceptualized in like the late 1700s, early 1800s, was basically you had these naturalists who would go out and they would observe strata, usually these well-known sites either in like England or France or Russia, and they would look at the fossil contents of those layers, and what then they could do was they could correlate the fossil content of one with the fossil content of another place, right? So if you go to England and you go to like what is it, Sicker Point, and then you go over to like France or Australia or wherever else, you can find certain
Maybe you
fossils.
go to the Jura Mountains to look for some Jurassic.
Yeah, I suppose you
fossils.
could do that if you were interested in Jurassic fossils, for instance.
Like me.
And what you can do is you can then correlate the rocks that contain certain types of organisms, like certain phytoplankton in one area, with rocks in a different area that also have those same phytoplankton in them. And those organisms are therefore called index fossils because they are very wide in distribution, but they have a very short vertical distribution in the layers. They're usually correlated with like one, you got this stratum, and then it's a change, and then there's a different one above that, then there's a different one above that. And so that is how they built the concept of the geological record and the fossil record originally. So there was no radiometric dating at all. But the fact that you have these correlated layers all over the planet indicates that these could not all have been laid down at the same time. It is just not possible. You would have to have. I mean,
why not?
So
Well, because
can water,
there's no sorting mechanism that would allow for this particular order of fossils, because the fossils are not
Right.
ordered according to anything that water normally sorts, right? So hydrodynamic sorting.
Well,
is
there is one answer to that, but it's not one neither of you will accept.
well, it's because it doesn't work.
yeah. So like, okay, so for
According to
instance,
your worldview.
No,
it
according to
just
physics,
physically doesn't work. Yeah. So like
Right.
if you take different like species of like foraminifera,
You
which
know
are
what
all,
event I'm talking about.
yeah,
yes,
and that's what we're
talking about
saying.
The flood, the
It
flood is
doesn't work.
physically impossible in the same way that anti-gravity is, as described in Genesis.
So
It's
but
not a physical possibility, and I
straw
can
man.
tell. No, it's not, because it's what was admitted to by the RATE team,
yes,
which is Radioisotopes in the Age of the Earth, which was a team of combined scientists, mostly from ICR and AIG, who got together for years to try to solve the problems of how radiometric dating and the heat problem with the flood can be solved. And their answer at the end of it was, we would need exotic physics. And when you dig into that, what they mean is miracles, which means we need to break the laws of physics. These are the top guys who are still around in young Earth creationism. Their conclusion was that for the flood to
I don't
happen,
dispute that we need a miracle.
so that means it's physically impossible,
right.
because the entire point of miracles is that they are suspensions of the normal operations of the laws of the universe to allow God to
No
create
one's
effects.
disputing that.
So yes, in that case, if it requires a miracle, it is physically impossible.
And it's not science, therefore.
And it's not science. Now, if you want to say that contrary
Well, it's
to
not
all the
anti-science.
physics,
It's just beyond the realm of science.
great. And if you want to say that contrary
It's
to
not
all
the
the
same
physics
thing.
and all the physical evidence, none of which even hints at a global flood ever occurring in the entire history of the world, that's fine. But once again, you're not doing science, and it remains the fact that evolution is the scientific theory. If you want to do something that isn't science, okay,
It's
that's
a theory.
fine.
It's not scientific.
Well, okay,
it
but
would
I'm
be
here to
an
talk about
untestable
science.
hypothesis.
Yeah, I'm here to talk about science. If you want to talk about not science, well, quite frankly, I think you probably picked the wrong channel, because I think Jackson is also here to talk about science.
Yeah, and so it's also very intriguing to me that you would take the position that the flood is inexplicable on physics, because there are other creationist channels here on YouTube.
Well, it is because I mean, if you look at if you look at the story of the Bible, I mean, okay, it's physically possible, but it would definitely be supernatural in design and order.
Well, what I mean is there are other creationists on Twitter, and in fact, most creationists at like AIG, ICR, CMI, they try to argue that there are physical mechanisms that naturalistic mechanisms that could cause the flood to occur, because they don't want to appeal to miracles, right? That's the major creationist organizations don't want to appeal to miracles. Now,
I don't care what appeals to whatever,
and that's fine. But what we're trying to say is, if you want to, what I think we're trying to say is, if you want to appeal to miracles, then yeah, you can do that for literally everything we talked about. You can say, well, the similarities between humans and chimps, miracles. The similarities between flies, miracles. And it's like you break the foundation for having a conversation about science.
Yeah, I mean, but I'm saying I don't mind appealing to miracles, but I don't also appeal to miracles at the point where I'm just going to chuck my brain at the door and say, well, okay, God can just do it. Like I hate the God of the gaps argument for the most part.
Mm-hmm.
Jackson, can I jump in real quick?
Miracles. Oh yeah, go ahead.
Pardon?
Because the thing that Dapper just said. So miracles are fine to start the flood. Did God also sort all the drowned animals and plants in different layers? Because that can't happen. That was Dapper's question, which
probably can't happen because you say it can happen.
No, so what we were talking about earlier with like the hydrologic sorting was that, like,
I hear a lot of that happening that can't happen. But
if you look at foraminifera, for instance, let's take one example, like phytoplankton, many of which are about the same size, same shape, very similar to each other. Or many of them are, not all of them, but many of them. And you try to put a bunch of these in water and then bury them, you are not going to get the graded distribution of phytoplankton that we observably see in the fossil record. You are not going to get that. And if you don't believe me, go test it. Go ahead, have fun. You can try it. Phytoplankton's still around. You know, you can take
it. It's not actually that hard to make a sedimentation plume at home.
It's not. It
requires plexiglass, some glue, a bunch of water, and a bunch of various sediment. That's it. It's actually pretty easy to do.
Yeah.
If you want to do a sedimentation experiment in which you can get actual phylogenetic sorting, or let's say just sorting by species, in phytoplankton or in these phytoplankton that are just skeletal, in the course of vertical strata as a result of a single depositional environment in a flood over the course of a year, actually would have to be a few months because you have to have time for the water to recede after Noah's already on the flood, because it only rains for about 40 days, and then seems like it settles down and then it drains off. So you actually really only have a few months. Then great, but so far no one has ever done that, and the fact remains that everyone who does do sedimentation experiments, everyone who actually checks hydrological sorting, everyone who actually checks what flood deposits that we know are flood deposits actually look like, comes to the conclusion that the geological column as it exists now absolutely cannot be the result of a flood, unless you want to say that it's miracles all the way down, right? Just like it's elephants all the way down.
But it actually does hinge on one very important thing, that the Earth as it is now was not the same before the flood.
We're talking about like suspension of physics again, and as Dapper said earlier, if you want to suspend physics again, you're just not doing science.
Yeah, I mean, you can do it. I'm not going to stop you. Okay. But I don't know why.
I don't think it's anti-science. I just think it's beyond science.
Anything in which you say, okay, let's take the things that science does and toss them out because I would prefer another thing, and then you also want other people to believe that.
Well, it's not about preference. This is where I think the evidence leads. This is.
But it doesn't. Like we can't get there.
According
we were talking earlier about the leaps in logic. This is a leap in logic. It is a leap in logic to say I see where the evidence is. But to get it to where I need it to go, I'm going to have to suspend the laws of physics to do that. That is a leap in logic that no scientist has.
I agree that to say no scientist is true. It's no scientist that you agree with, Jackson.
None of them do it. Like, I've read a non-trivial number of technical papers.
You're using confirmation bias, and I'm not going to let you get away with it. It's not scientists that you agree with, and I'm not going to let that fly. So just let me sit clear.
It is none of them. None of them do it. I've read a non-trivial
Okay,
amount of scientific
Jackson, I'm just
literature.
going to say flat out, you're
Dapper
lying
has
to
also.
yourself. You're lying to yourself. So stop.
Okay, that's
Cool.
coming from the guy who thinks that limestone followed by sandstone above it was deposited by a single flood, my guy. You're the guy who's saying that Jackson is lying to himself about that.
I'm not. Yeah, but I'm agreeing with that. I'm not lying about it. I'm saying that there's science can only go so far. That the science has limits.
You've never produced any of them.
Yeah,
Well, this is a debate. This is a debate. We're not. This is not a.
I mean, as far as I can tell,
debate.
it's more of a very, very loosely structured chat than a debate. We didn't have any time.
Well, that's according to your opinion. According to your opinion and your worldview. You can shake your head and disagree with me all you want. I don't care.
About whether this is a debate?
No, but whether I'm talking about scientific stuff or not. I think I'm talking about stuff that just doesn't fit your narrative and your worldview. Simple as that.
I don't think you know what the worldview of either of us is that you could actually say that, first of all.
I've got a pretty good idea. I mean,
don't
Jackson,
think you do. Jackson's, to be fair, is a little bit more open about that than I tend to be. I don't think you actually have any good reason to think that you know what my worldview is, other than that I accept science.
According to you.
No, according to what is actually in the peer-reviewed literature and what is the consensus of everyone in the fields that are the scientific fields.
So truth is by consensus. Great. Right.
No, what
Yes.
things count as science is indeed part of what the scientific consensus is. Now, what science is can in fact change over time.
Consensus doesn't
But
equal truth. You got to get that through your head.
Okay. I am going to try to explain this as easily as I can. At one point, it was indeed scientific consensus that light needed a physical medium in which to propagate, and that was called the ether, the luminiferous ether. Also, at one point, it was thought that the substance of fire was phlogiston, which was contained in flammable materials and was released into a bright flame when those things got hot enough. Both of those things were the scientific consensus, and they were science. It is true that neither of those things are currently the scientific consensus, and that we have changed what the science is in terms of how fire works and how light works, the propagation of light at least.
We changed it or we discovered it?
Both. On the basis of the fact that
it's not the same thing. You got to be clear in your terms.
On the basis of the fact that evidence did not comport with the predictions of those two ideas, the consensus changed because people changed their minds. What science
because they discovered was something was what they thought that was right at first.
Yes.
Wasn't right. That's called discovery, not
yes. And in fact, we discovered that no, in fact, the entire geological column is physically precluded from being deposited by a flood, and therefore we abandoned the idea of a global flood as the major contributor to the geological formations of the Earth because it is physically impossible.
Most people.
Great, and I'm sure you can find some idiots who accept phlogiston.
Oh, so now we're resorting to ad hominems, are we?
No,
that's
no, we're
technically not what
an ad hominem.
That's technically not what an ad hominem is. That might be an insult, but not an ad hominem.
At what point did I say
ad hominem? Either way, we're resorting to insults now, are we?
Anyways.
No, I would like
and you
to
said
talk
I was
about
being
ad hominem
contentious.
thing.
Come on, man, you're a hypocrite.
Oh, I'm a hypocrite.
Cool.
Yeah, you said those were idiots. That's a hypocrite. You were saying that I was getting contentious with Jackson earlier. Now
Rob,
you call people idiots.
Rob, guys, hold on. Rob, just checking. I just watched a video on your channel. Did you say or did you not say that all atheists are idiots?
No, I said they're all.
Shall I link you to the video because I just watched it.
Idiots.
I just watched it.
Rob,
You said. Hold on. I can link you to the video. You said all atheists are fools, and then you went on to say, well, actually, they're not fools, they're idiots. I can link you to the video on your channel.
Who'd have thought that Rob might
And you tell Dapper he's a hypocrite. Sorry, I had to jump in because I just watched it.
If I had a Pikachu avatar, I would use it with a shocked face right now. I should probably get one of those because holy crap, it turns out that the guy who doesn't know what the word morphology means and wanted to have a discussion about evolution and who accused me of being a hypocrite for calling people who believe in phlogiston idiots has a video on his own channel in which he says that atheists are fools. No, wait, they're idiots. Oh my God, I cannot believe that this happened on today of all days here in the year of our Lord 2024.
Year of our who?
Thought about it.
Okay.
Year of our who?
Anyway.
Yeah, the year of our Lord, Rob. What are you going to go with? What are you going to say about it? You don't know if I'm a Christian or not.
I posted the link to the video. I posted the link to the video. Hold on. I posted. Rob, I posted the link to the video in the side chat and in the private chat here.
You need to calm down.
Okay.
So,
anyways, moving on.
People can go check.
Moving on.
Oh yeah, here it is. Here you are.
Let's try. All three of us. Let's try to have an adult conversation without either of us losing our cool. How's that?
Hey, how about in case of that, you stop special pleading, you stop straw manning, you stop projecting your own hypocrisy. How about that, Rob? Would that be a good start?
How about you do the same thing? And how about you calm the heck down?
I am very calm. What I am is
no, you're not calm. You're emotional. It's very obvious you're emotional.
Yeah, I am in fact emotional because I'm having a lot of fun. I do this for fun, Rob. What, you think I just randomly decided one day at 3 p.m. on a Wednesday?
All right.
You're just
this is devolving into a dumpster fire.
Oh, I might.
It is.
Jackson, come on. You brought on the guy.
I just asked that Dopper stop the conversation. Me and Jackson actually do this because me and Jackson were supposed to be the one.
Well, I said in our emails that Dapper was going to be here because I always have these conversations with Dapper. It's always the two of us as
and it actually usually goes very, very well.
So anyway, okay.
So that
anyways,
okay. So it's obviously all my fault, right, Dapper?
Well, you're the difference between all the other times, right? All the other times that myself and Jackson have gotten together to have a conversation with someone who's blatantly wrong about science. We have a very cordial discussion.
There we go. So not blatantly wrong, but your perception of science. There you go.
My perception, as well as the perception of all of the scientists, bar a fraction that is less than 1%. Yeah, that's what science is. And yes, they 1%. Have that. Yeah. If you
you've taught, there's 8 billion people in the world. You know that only 1% of them just.
He said scientists. He said scientists.
You really think 1% of scientists of 8 billion people?
No, I think less. I think. What are you even talking about?
Less than 1% are creationists. Yes, this has been polled many times. This poll has been done many times by the American Association for or whatever it is for the Advancement of Science, the NCSE. Lots of different groups have done this. Anyways,
yes. Anti-evolutionists make up a bit less than 1% of all active scientists.
So, I mean, what we're trying to say is yes, what we've been talking about has been the scientific consensus and is based on the evidence. What you have appealed to is you have special pleaded in the cases where you seem to think that the evidence does not support you. For instance, we were talking about the geological record, right? There are mechanisms for the deposition of layers with organisms within them, right? We know a whole lot about how organisms die and how their parts get, affected by the soil chemistry and the pressure of more layers bearing down on things.
No one's disputing that.
Okay, but what I'm saying is, in the model that is, the consensus, the model that is the consensus of the scientific community, this is a purely naturalistic phenomenon. There is no need to suspend the laws of physics to accomplish this, right? That's just not a thing. And what I've been saying is, one example of how we can, show that that's all that's needed, and we don't need, or this isn't explicable via a flood, is, for instance, the deposition of index fossils, right? Particular index fossils do it.
So let me ask you this question just on the face of it.
Okay.
Do you reject the flood on the premise that's a supernatural event altogether?
Not really. I mean, like I said, there are lots of creationists who
just yes or no. Just yes or no. Just yes.
The flood doesn't have to be supernatural. It could be totally a naturalistic event. That's possible.
Okay, no, but would you reject it on the premise that it would be a supernatural event? That's the question I asked.
If it were a supernatural event, that would be beyond the purview of science.
Yeah, but that doesn't answer my question.
I'll just answer it with a no.
Isn't that what you asked me?
I said as yes or no. Would you reject it on the premise of it being if it wasn't?
I can't reject it scientifically. I can't confirm it or disconfirm it scientifically because science only works.
That's fair. Okay, all right. Let's move on.
Okay, so because so at any rate, the model that we do have for sediment deposition is a naturalistic one, and it does account for the available evidence without having to suspend laws of logic. Now, it could be the case. This is totally wrong.
The only thing you would have to import is, of course, long epochs or periods of times,
which we do accept, right? I mean, the consensus is that the Earth is very old, and this is one of the ways we can confirm that. As far as we're aware, and barring the laws of physics not upending themselves, it seems to be the case that these phytoplankton are arranged in the layers by species, and this is a result of them being at different time periods from each other. Like one species is at a certain time period, another species is at a different time period, and so on and so on. Like that's a relationship that can be verified in multiple independent ways. We can see this in chronostratigraphy. We can see it biostratigraphically. And then afterwards, we can apply radiometric dating to it. And we can say, oh, look, this also accords with, it gets older the further down we go, or farther down, whichever one. Okay. So those are different independent metrics by which we can verify or, evidence this idea, right?
Right.
Does that make sense? You see what I'm saying?
It does. Yeah, it does. No, it does.
So okay. So given that it seems like the Earth is old and these sediments get older the further you go down, and we can see that there is this correlation between phylogenetic divergence, so the separation of lineages, and these converge the further we go back in time, right? You'd say that is a prediction of evolution, right? That the further you go back in time, the closer two lineages come to each other until they meet at their common ancestor.
But as terms of a prediction is concerned, it's something that we have to infer, can't prove. Are we really in agreement on that?
Well, you can't prove anything in science, right? That's math or philosophy. You can't ever prove
anything. I suppose that's true. Yeah. I mean, what I'm saying is you can try to use this as a model for induction, but you can't say it's necessarily scientific. It's just
technically predictions are deduction, but yes, it's an abductive model overall, which is what science is broadly. It's abductive.
Yeah, which means it's a theory and it's not scientific in nature.
No.
Maybe it's a scientific model, but it's not scientific.
What does that mean?
No, I'm not sure what you mean, because when you do science is itself abductive. You use both induction and deduction. So you use.
I agree. I would agree with that. Right. I'm saying because it's from times past that you weren't there to see it, that you can't say it's definitive. Is what
we're back to the tree. We can't see the tree grow, so we can't say anything about it. It's not scientific.
So what we're doing, so Rob, what we're doing when we say that is we're taking points of data. We're doing induction. We're taking points of data. So, for instance, you can see a seed, then you can see a sapling, then you can see a tree that's 40 meters tall, and then you can see a tree that's 80 meters tall. But we didn't observe at any point one of those becoming another. We observed the different steps, right? It's kind of like if you were, like a mosquito, flying around in like a developing neighborhood. You see a house that's just a base, then a house that has the base and the walls, and then a house with the base, the walls, and the roof. But you, as a mosquito, don't ever live long enough to see one of those become the other. But you can infer, you can use induction to reasonably, I think, conclude that that's the base and then the base with the walls led to the base and the walls with the ceiling. So
no, that's a good analogy. I like that.
So we're applying the same. We're trying to apply the same reasoning. I mean, and forensic experts do this all the time, right? So, and if you're in forensics, there's like no camera. Someone got murdered out in the woods away from everyone else.
Got DNA and fingerprints and all that stuff.
Yes, exactly. But those allow you to again infer. Those are what's the term for it? What type of evidence is that?
Circumstantial.
Are you looking
circumstantial? There you go.
Fingerprints are definitive. The evolution theory isn't.
Okay, but here's the thing about that. Again, we're talking about you have to weave that into a narrative about what all the evidence says, right? It's not just you can't just okay, your fingerprints were on the gun. Well, you can't use that alone to conclude that so-and-so committed the murder because maybe they touched the gun before the other person did, right? And so there's no connection whatsoever.
Maybe they got the fingerprints of someone else implanted to the evidence.
Right, exactly. So you have to look at all the evidence, and then once you evaluate as much evidence as you're able to, and then you can use that evidence to make a conclusion, right? You're going from a bunch of data points to a conclusion. That's induction. So we're doing the same thing with evolution, right? We're taking these points, these like whether it's transitional fossils or these changes in the genome, and we're using these small scale changes that we've talked about, whether it's microevolutionary mechanisms resulting in separate species, and we're using these things we can see on our human timescales to extrapolate to things that we are unable to see on human timescales. And I think the through logic of it is very solid because I'm not appealing, Dapper's not appealing, we're not appealing to any new or separate mechanisms in the change from, a semi-aquatic whale to a fully aquatic whale than like from a fruit fly to another species of fly. There's no new mechanisms that are happening in that process. And so when we allow one, it seems that we should allow the other one to occur because the logic is exactly the same. There's no jump from one thing to another. It's the same process.
The difference is quantitative, not qualitative, in terms of the difference between those two.
Does that make sense?
It does.
Okay. So given all that, it seems to us and to the consensus broadly that the evidence for evolution is pretty solid. We have our inductive methods, and then we actually have our deductive methods. We can make predictions about what evolution should expect, and then we can either confirm those using model organisms, or we can go out into the field and search for particular fossils, and that happens. There are lots and lots of fossils that were predicted to be in specific areas.
At this point, it's virtually all of the ones that are discovered now that have any scientific significance.
Yep. What's up?
Okay, this is what I propose.
Okay.
I'm just because I'm a creationist, so I'm gonna infer the Bible all completely. Is that if I believe that if God created the world as he said, it says that he did in Genesis 1, then I'm going to infer that the world is one created with age. So if God creates a garden with trees and flowers and birds, that if you cut the tree down, there's going to be rings in it. That's what I'm going to assume about the creation of the world if I stick to the narrative of Genesis creation story. That makes sense?
Yeah, but I've just become
one thing at a time.
I've just become a young Earth creationist.
No, just one thing at a time. Okay.
No, but it's okay because I'm a young Earth creationist now. I'm with you. I'm a young Earth creationist now. I'm with you because I like the appearance of age. Although I think the Earth is way younger than you think. I'm going to go with the Earth actually was created last Thursday, and all the things that seem like the appearance of age were just supernaturally created with the appearance of age.
Okay, if you don't want to have a serious conversation, you can just stop talking.
So that is an actual philosophic rebuttal to what you're proposing is what's called the omphalos hypothesis, or omphalos. It's Greek. I don't know how to pronounce it. Is that like things were created with the appearance of age? A typical rebuttal to that is what's called last Thursdayism, which is where the Earth, which you could apply the same logic,
right? Silly argumentation.
It's not though. It's the same logic.
Well, it's as silly as the omphalos argument is in the first place. That's the thing.
I'm not done yet. I'm not done yet.
Okay.
Jeez,
Rob, you've been done for a while.
Especially Dino. What's that?
You've been done for a while.
Go ahead.
Okay, then if you could just continue listening and not talking when I'm talking, that would be great.
Okay.
So my second point would be, of course, as I've already mentioned, is the Bible says in Genesis 11 that everything produces after its own kind, which I've already explained what I mean by kind. So I didn't need to further.
Well, you failed to explain.
I don't need to repeat. According to you.
Well, according to anyone who can think well.
So when we say
according to you, that everyone can think well, and I don't think that you think well, so that doesn't mean anything to me. That's just subjective.
I know you don't, Rob. But
every time we brought up the issue of kinds, what we've kind of run into is the issue of like this sort of asymmetrical problem, right? Is that you allow certain things to be part of the kind, but there's this inconsistency. It's some things allow a greater degree of diversity compared to other things. And what I don't think we've gotten throughout this conversation is why there's that asymmetry, that inconsistency between different groups. We could say, for instance, because we already agreed, evolution says that if you have like flies, for instance, Diptera, the entire order of flies, that group, no matter how far in the future we look, Diptera will always encompass those later descendants. That is evolution, right? That's monophily. You can never escape your ancestry. So, for instance, we
No one's
are
saying
you.
you can.
Well, okay, but that's agreeing with evolution. Evolution says that. So we and oak trees are both eukaryotes. Eukaryote means that we have a nucleus in all of our cells. It's so we have a nucleus in our cells, whereas bacteria don't. So we, us humans, and elephants, and and birds, and worms, and plants, and mushrooms, we are all eukaryotes. So forever from now till the heat death of the universe, if we survive that long, if our lineages do, we will always be eukaryotes, right? Because we are part of that group that is in our ancestry. So we are encompassed by that group, so we can never leave it. So you could say eukarya is a kind because we can never leave it. That is a lineage we will never escape from forever and ever. Do you see what we're saying? Does that make sense?
It does.
Do what?
I think that was a yes.
Yes?
Yeah,
Okay.
I said it does. I said
So
it does,
couldn't eukarya just be a kind? Because we'll never escape from it. We will always be part of it. We will always reproduce eukaryotes forever.
You're talking about eukaryotes, not us, right? I'm just making sure we're clear.
Well, that
careful with
includes
the
us.
words.
We are eukaryotes.
Oh.
So we are part of that group because we have nucleus in our cells. So because we and oak trees and mushrooms will always reproduce eukaryotes forever and ever, shouldn't eukarya just be a kind?
I mean, I'm not sure I entirely understand where you're going with this, but let me just put it in a way that I
mammals.
understand.
Or mammals.
Okay,
and
I understand that. Okay,
so
this is a different kind of question altogether. You know that bananas and humans share 50% DNA, right?
I actually don't know that. I've seen that number thrown around. I don't actually know if it's true.
Okay, well, let's say we're an example that DNA and humans have a high percentage of the same DNA.
From what I've been able to check, it's closer to 30% than 50. But
okay, well, it's even 30%. Would you say that's proof of humans and bananas having a common ancestor?
I would say the fact that we have a core set of eukaryotic genes between us is evidence of our common ancestry. Yes, not just that we.
And I think that's an insane thought. But that's
so
me.
I don't understand why, because the same argument can be made for really us. If I say, for instance, I have never seen our common ancestor. I have never seen the common ancestor between you and me. I don't think you have either. So based on that, how can we say that you and I are related? We would have to use this. I doubt there are records of who our common ancestor is. So given that we don't know who it is, we have no historical records, we can't see who it is, how we know? We have to use genetics and we have to use morphology and anatomy. That's how we know. We understand that we're the same species, most likely, because we have a suite of characteristics that identifies us as the same species. That therefore means that we share common ancestry.
And again, I think that just all of that proves is commonality, not common ancestry.
Okay, so are you saying then that we don't share a common ancestor?
Exactly.
So you and I don't share a common ancestor.
No, we do.
How do you know?
We and bananas don't.
How do you know we share a common ancestor?
Scientific method, induction, inference, logic.
What specific evidence can you look at that indicates we share a common ancestor that doesn't indicate that we share a common ancestor with anything else? Because it's the same evidence.
We have genetic information in our DNA and limitation in the gene pool.
So
that would
again,
suggest that we can't be anything else but have a common ancestor.
So there's no evidence of this. You keep referring to like there's some kind of determinant in our gene pool that prevents us from evolve. That's just not a thing. It doesn't exist. Like, there's no evidence it exists.
Or at least no option for it has been ever produced.
Right. If it does exist, if it's entirely possible, it could theoretically exist.
If is a big and this is big and that's where I think evolutionists always, like yourself, get stumped in, is that you're always appealing to the what ifs, not the what is.
No,
Well, I mean,
I'm only
this is
appealing to
explicitly
genetic evidence.
anti-evolutionists. Yeah, this is anti-evolution people saying, well, if there's a barrier, okay, well, is there?
Yeah,
I mean, it would be a great research avenue.
I mean,
for
at the end of the
creationists to
day,
find
at the end of the day, this is a philosophical worldview dispute more than it is science.
It's really not
science.
though, because when
It
I
really
say
is.
so, when I say we use that, someone would have to demonstrate that you and I are the same species. We would look at our genes, and or not just to demonstrate that we're in the same species, but that we share a common ancestor. We would look at our genes.
Yeah, when the thing is the difference between you.
Like, I don't, what I'm not understanding is how that differs in any way from showing that we share common ancestry with chimps and with orangutans and
because you and
I
have the exact same genetic structure.
We don't,
for the most. Within a very minute possibility. Like,
okay, but you understand that within other species there can be greater than that amount of difference, right? Like, we're an extraordinarily homogeneous species. It's like very, very, very similar, but you can have greater than that amount of diversity within other species, which therefore means that, you know,
and importantly, the genetic diversity between species, between humans and chimpanzees, is smaller than it is in many other species. For instance, it's much smaller than the difference between tigers and lions.
Right.
But I don't hear lots of creationists saying that for that reason, we should say that they don't have common ancestry. In fact, most creationists that I hear would argue quite strongly, and I think correctly, that lions and tigers are actually closely related, both being in the same genus and and having limited interfertility. We don't actually have a lot of good evidence either way for interfertility between humans and chimpanzees, although we actually do have positive evidence of her limited interfertility between humans and hamsters.
We sure do.
That. Yeah,
we sure do. Unfortunately,
the hamster is a thing that has.
I'll tell you what: if you get a chimp and a human together, that could produce something, then I'll change my mind.
Well, for ethical reasons, I would oppose that reason.
I would also oppose that. Yeah.
Well, of course, I'm just saying on the base of the scientific model itself, that would definitely prove your theory beyond. It
would be an interesting conclusion to read about. It would be a horrifying experiment to conduct.
I just like you, am opposed to bestiality for many reasons.
So it's just the issue that we kind of keep coming back to is just this issue of inconsistency, right? We're just saying,
the thing is, I know it sounds inconsistent, but the thing is, I know it's true. I just know it's like, I know that sounds like an argument from incredulity, but it's like, there's some things that I just know that I can't prove.
Okay, what I'm saying is, because I'm going to wrap this up shortly, is going forward, just if you think about this in the future, you have this issue of, creation, evolution. Just consider that there may not be actual reasons for it to be inconsistent, right? Consider that maybe it just is inconsistent, and that there is an alternative that there could be, right? It doesn't have to, that isn't inconsistent. It doesn't have to be this way.
There's lots of inconsistencies with macroevolution. I've already brought them to your attention, but you don't accept
we haven't discussed any. But what I'm trying to say.
Exactly. No, it's just as I said, Jackson. It's not that you accept it, and you can say whatever you want, but I don't care.
Calling it confirmation bias. It's really not. I accept the fact of evolution. So what I'm saying is, in the future,
that's the thing, is I don't accept it as
whenever you're thinking about this again. Just
acknowledge facts don't care about your feelings.
Just acknowledge that there are ways
we had to pull out Shapiro
to make your argument not inconsistent. There are ways to make the argument consistent, and the way is evolution. It is you just use the same line of data, which is genetics.
It's massively inconsistent.
You just apply that same standard to the next thing. You just take it from humans, which you are applying it rigorously in this case, and just keep applying it rigorously. Just go to the very next thing.
Humans only produce humans. Apes only produce apes.
Eukaryotes only produce eukaryotes. We've already agreed on this. Eukaryotes will always produce
there will never, ever be anything else other than that. Ever.
You're right. There will never be
Yep.
other eukaryote, or there will never be non-eukaryotes
There will never
produced
be
by
a
eukaryote.
human. And there will never be a chimp eventually becoming a human. There'll never
That's
be a mouse
also true
becoming a
because
cat.
those are separate lineages. That is
Rob,
also true.
I want to point out that saying things that evolution says are true, but saying it in a mocking manner while also agreeing with it, isn't the argument you think it is. In that it's not an argument.
We agree. Humans will never give birth to chimps. Chimps will never give birth to humans because we don't expect that in evolution. We share a common ancestor with them. That is a parental population.
I disagree with that too. There is no proof of common ancestry. There's only proof of common genome.
Okay, so that means you and I don't share a common ancestor.
No, we can't demonstrate it.
No, we don't. No, we don't, because it's common design. All the similarities in our genomes are just common design. You cannot persuade me otherwise.
Okay.
You understand that line of logic, right? Because if you're going to say thing X is just common design, I'm going to say that for you and me. We're not actually the same species. You and I were separately created. You can't argue with that. There's no line of logic you can pick that invalidates that does not also invalidate the argument that we share a common ancestor with
Jackson,
humans and chimps.
Have you considered special pleading?
I have considered special pleading.
Okay.
Yeah, the thing is, you're using special pleading with your own art, with your own theory.
There's
it has to be this, and it can't be anything else.
No,
you don't even see it.
You understand the dichotomy, right? You understand that either you use genetics.
No, I'm saying we're both playing the same game. It's just I'm the only one who's willing to admit it.
Either we use genetics to indicate that you and I share a common ancestor, and that's not common design, or we don't share a common ancestor and it is common design. Those are your options, right? It's one of those. It's either common design or it isn't.
I'm aware of that.
Okay. So given that it's either common design or common ancestry, for us, what is it?
Common design.
So we don't share a common ancestor? Okay.
That's what common design with. I said both. Actually, sorry, I said both common design.
How can it be both? What do you mean? What is? Wait.
Everything's been created by God, and we have common designer because we're the same species and same kind.
How do you know that?
I don't
think you know that Jackson's the same species as you.
Well, I can't prove it because it's out of the purview of scientific.
Well, we're not talking about you to prove it. We're asking you to provide evidence for it.
Yeah, why do you believe that you and Jackson are the same species?
Okay, well, because I can only use induction. So there's over 8 billion people on the planet. No two people have the same two fingerprints. Every human body has over 3 million light sensitive cells per eye. The human brain makes over 1 billion calculations a second. The gravitational force is precisely where it needs to be for the conditions of life. The sun is exactly where it needs to be.
I don't know what any of that has to do with demonstrating that we're the same species. I mean, like that. None of that has.
No, sorry. I was giving evidence for design.
No, why do you? What is the reason that you come to the conclusion that you and Jackson are the same species?
Because of our DNA, we're both humans. We're both Homo sapiens, and we would.
Based on what?
Yeah, maybe Jackson is actually like Homo alabamensis.
Well, I'm not going to deal with hypotheticals. We're going to deal with the reality. So I'm not interested in that kind of debate.
Okay, so what I'm just hearing is that you think that Jackson is the same species as you because you think he's the same species as you. I mean, okay.
Yeah, I would think that's logical, don't you?
No, because that's just circular. Because A, therefore
circular doesn't necessarily mean fallacious.
Yeah, I know. You said that in Steve's debate the other day. I know. But what we're trying to find,
you and I agreed upon it, so I don't know why you think you're smarter than me and Steve together. Interesting.
No, I'm not disagreeing with that. I'm just identifying that you guys talked about it the other day, and it's correct to say A equals A. What we're saying is you're not appealing to evidence. You're just special pleading again. At any rate, it's been 2 hours.
Here's the thing I'm saying. It's like,
okay, say your final thing, and then we're going to cut it.
I'm the only one who's willing to admit it because you have to use special pleading for the same theory of evolution that you have to rule out everything else by definition. And
what am I special pleading to say that you and I are related via common ancestry and also we're related?
You're special pleading by saying evolution is true and evolution can't be true because.
You've already agreed to
special pleading. You're playing the same game. You just don't have the intellectual honesty to
agreed to all these terms. Anyways, it's been 2 hours. So thank you, Rob, for coming on. I appreciate it. Thank you, Dapper, for coming on. I always appreciate you co-hosting. Thank you, Peter, for producing as always. It's very kind of you.
I didn't realize it's been 2 hours. That's crazy.
Yeah, it goes fast.
And thank you everybody who was watching in the live chat. We are gonna
hit like, everybody.
Yeah, hit like, or else I'll hit you with a stick. I don't know.
Yeah, he'll come to your house and he'll slip fish down your shirt because he's got lots of fish. He's gonna get them from the aquarium.
Yeah.
Once you want a fish wriggling down the back of your shirt, hit like. He can find you.
We
Like
have
Star
the
Song right
means.
there. Star Song. He'll come to your house personally if you don't hit like.
Okay,
All
all right. Thanks, guys. It's been fun. It's been a little heated at times, but hopefully we don't hate each other. I just don't hate you guys.
Oh,
And I hope you'll
Yeah.
come to the Lord Jesus Christ sometime. That's my prayer in all of this.
If I haven't already.
Okay,
All
if
right.
you haven't already,
All right,
you may
Peter, we
as
can
well.
cut it.
Yeah,
Thank you. Bye,
real
everybody.
quick. Hang around, Rob, for a sec.
Yeah, I answered you in the chat, Pete.
Oh, okay. Looks like we got it. Yeah.